Now we're going to talk about odd and even functions. Look at the notes in your notes handout and fill in the information, add your own comments that are helpful to you. All of these functions are in the same category. Can you tell how they are all alike? You can see that each one of these is a mirror image across the y-axis. They look exactly the same on both sides of the y-axis. They are symmetric with respect to the y-axis. These are called even functions. They are symmetric with the y-axis. For example, we have f of x equals x squared, the parabola you see in the graph. That is an even function. We know that f of 2 equals 2 squared, which is 4. We also know that f of negative 2 is negative 2 squared, which is also 4. So one characteristic of an even function is that opposite inputs give you the same output. So we can say that f of x is equal to f of negative x for all values of x in the function. And as we saw on the previous page, the graph looks the same on both sides of the y-axis. If this point is on an even function, what other point do we know? 3 nines on the function, negative 3 nines on the function. Negative 2 13 is on the function. Negative 2, or positive 13 is also on the function. Opposite inputs give opposite outputs. If negative 15, negative 24 is on the function, then positive 15, negative 24 is also on the function. Opposite inputs, same output. If I earlier said opposite inputs, opposite outputs, I didn't mean that. I mean opposite inputs, same output. Negative 103 smiley face, positive 103 smiley face. Pre-calc awesome, negative pre-calc awesome. X f of x, negative x f of x. So opposite inputs give you the same output for every single point on the graph. Now these functions clearly are not the same on both sides of the x-axis, so what makes them special? Ooh, if this graph is rotated 180 degrees, it's the same on the other side. Ooh, that should look familiar. That's a sine graph. So notice what we have here is that the graph looks the same in opposite quadrants, only rotated around. Okay, so if you took this whole graph and just rotated 180 degrees, turned it upside down, it would look exactly the same. These are called odd functions. They are symmetric with respect to the origin. They rotate around the origin. If I were to rotate this graph 180 degrees, it would look exactly the same upside down as it does right side up. This particular function is f of x equals x cubed, and it is an odd function. Notice if we put in 2, we get 8. If we put in negative 2, since a negative number raised to an odd power is still negative, we get negative 8. So opposite inputs, instead of giving you the same output, opposite inputs give you opposite outputs. So we say for every x in the domain, f of negative x is equal to negative f of x. Another interesting feature of this graph that any time you have these pairs of opposite points with opposite coordinates, a line connecting those opposite points will always go through the origin. So if this point is on an odd function, 2, 8, what other point do we know? Negative 2, negative 8. Negative 2, 13. Positive 2, negative 13. Negative 15, negative 24. Positive 15, positive 24. Negative 103, smiley face. Positive 103, frowny face. Corgi awesome? Negative corgi, negative awesome. I got this from a teacher who apparently likes corgis. X, f of x, negative x, f, negative f of x. So to summarize, for any point x, f of x on an even function, there should also be a point negative x, f of x. For any point x, f of x on an odd function, there should also be a point negative x, negative f of x. So if you're doing an algebraic check for even functions, you just put in two opposite values for x and make sure that your output is the same. For an odd function, you put in two opposite values for x, and you should get opposite values for y, or opposite values for f of x. The graphical check for even functions, the graph looks the same on both sides of the y-axis. The graphical check for odd functions, the graph looks the same in opposite quadrants when you rotate it 180 degrees. That is the end of our recording.